So just to review yesterday, we'll take 51 and kind of use it as a little bit of a review first. They're giving us an initial point, and they're giving us a terminal point. And if you graph these on a graph, this is a line segment that's going from -3, 1 in the direction of 4, 5. Now, I want you to notice that on some of the test questions, the way the book, I use the exact wording the book did. So, like on number 1, notice it says if you use a vector with terminal points 2, 4, and 6, 5, when you go plug this in, and it's got a vector v, it didn't tell you which was the beginning and which was the end, did it? The math is going to work out the same no matter what, okay? When you're showing those vectors are the same. We're just, we worked on that yesterday. They didn't specify which was beginning and end. It's okay. The math's going to work out no matter what, okay, as far as showing that they've got the same magnitude and the same slope. Notice number 2 is the same way on the test review. Here they're real careful about initial point and terminal point. It's better to know the initial point and terminal point when you're going to give the direction. And so when we're talking about direction, we kind of need to know which is the terminal, which is the beginning, all that. So here they're real careful. If you remember what we did, if we wanted to find, one way to represent this vector was to do this. The book has all this stuff in there where it labels it kind of weird. But what we basically do is we take our x's and subtract them. So it's this, I could say, okay, I've got a 4 here, 4 minus 3. I've subtracted my x's. And then I'm going to subtract my y's, 5 minus 1. And I could represent that vector just by finding the differences in the x's and the differences in the y's. And I could represent that vector, 4 minus 3 would be 7, and 5 minus 1 would be 4. Okay? That was one way to represent the vector. There is another way to represent it. If I look at this as the x part, and this over here is the y part, I could write this, what they say, they call this writing it in a linear combination form. And here's what they mean when they say a linear combination form. They want you to say, okay, that 7 is the x part. Instead of writing 7x, though, it's kind of weird, they call it I. Your x's becomes I in vector form. It's like all this stuff is really similar to stuff you've done before. They just use different letters for everything, so it seems a little confusing. Now, the 4 would be the y part, right? If you're looking at this, as it has an x part and a y part. So what do you think they're going to call the y part? If x is I, guess what the y part's going to be? What comes after I in the alphabet? J, okay? I could have a 3-dimensional vector with a z part, if we were talking about a 3-dimensional space, and it would just be the z part, the 3rd-dimensional part would be the k. You would just do it all the same. Here we're just talking about a 2-dimensional vector, like graphed on a flat piece of graph paper. So it's like the differences in the x's give us the x part, the differences in the y's give us the y part. The book is kind of weird because it labels them. If you look in the book in the formulas, this would be like 0.1, the x part, the second part of 0.2. We're used to saying, like, you would think they would have labeled this P1 and number 4 would be Q1 or something. And then, I'm sorry, P2. Well, I said I wasn't going to do that. I wasn't going to confuse. Anyway, I've already done it. Over here, the book labels this point Q, so this is Q, the first part of Q, the second part of Q. And then the book gives you the formula where you're subtracting Q1 minus P1, Q2 minus P2. Basically, if you can just realize that all you're doing is subtracting the 2x parts, subtracting the 2y parts, you can write this. This one right here, this form again, is from yesterday, is called component form. And this form right here is called the linear combination form because we're actually putting variables in it kind of like we would if it were a line. If we put like 7x plus 4y, it might look more familiar to us, but this is linear combination form. And so that's what you're doing in 51 and 53. Okay, so I want y'all to take a minute, and I'll write it up here so you can see it. Your initial point is -1, -5. And your terminal point is 2, 3. And they want you to write it in linear combination form. So pretty much first you have to do that component form first, just to do the subtraction of the x's and the subtraction of the y's so that you could write it that way. So what you'll do is first subtract your x's and y's and get it in component form, and then you can take component form and add in your i's and j's. All right, so what we do, and again, I'm not going to use the formula in the book because I think it's confusing. We go to the terminal, the ending point, and we subtract the initial point. And again, on the test on 1 and 2, you're going to be doing similar things, but it's not going to matter. You're going to get. I would always just go to the second point and subtract the first point out if it's written in those directions like that. But that came from your book. So, okay. So if I'm subtracting my x's, let me start over here. 2 minus 1. Well, what's 2 minus 1? That is 3, okay? So that in component form, I would write it there. If I'm going to write it in linear combination form that they asked me to write it in, that would become 3i. Everybody get that so far? Okay, and then on the other part of it, you would say 3 minus 5. Well, 3 minus 5 is, 3 plus 5 is 8. So that would be plus 8, and I would put a j there, and that's what they're wanting in that problem. But this is what we did yesterday when they asked us to put it in component form. Okay, so